When we study statistics, one of the key things that we need to ask ourselves is, where is our data coming from? How do we collect it? So typically, we might collect our data from a whole population. Okay, so what is a population? So a population is a complete collection of people or objects from which we are collecting data. Okay, so what does this mean? This is going to depend on the type of data that we're collecting. So for example, if we want to know the favorite color of all the people in the US, then the data would include all the colors that people tell us, and we would be asking every single person in the United States. That would be a population. Okay, so, and the population changes depending upon the question. If I wanted to know the favorite subject of every student at BMCC, then the population would only be the students at BMCC. So the population isn't the whole world, okay? The population is only the information that we want to get about a specific group of people, and it would be as if we're asking every single person in that group, okay? So this can vary depending on the question. Okay, so for example, if I want to know how many people, or if I want to get information on the number of stuffed animals children ages, let's say 5 to 10 play with in the United States, for this, the population would be US children ages 5 to 10. Okay, so again, it's not every child, it's only children who are between the ages of 5 and 10. Another example would be if I want to know the types of jobs that students at BMCC have. Then here, the population would be all students at BMCC. And notice the use of the word all. That would be true in the previous one also. It would be the population is all US children ages 5 to 10. So we're taking the entire group that we're trying to get an answer about, okay, that we're trying to make conclusions about. That would be a population. Now here's the thing. it can be really hard to get information from a whole population. How do you ask every single student at BMC? How do you make sure that they answer you? If you send out a survey, is everybody going to have access to the survey? If they all have access to the survey, are they all going to answer the survey? How do we access children ages 5 to 10? Maybe some parent doesn't want some stranger going over and asking their child how many stuffed animals they play with, okay? So because of that, okay, and also think about the sheer number of pieces of data that we would have, right? There are 25,000 students at BMCC, or upwards of 25,000 students. Sometimes that can be a tremendous amount of data to collect and to deal with. So we don't really always take all of the data from a population. We have to be realistic. So what we do is we take data from a sample, a subset of our population, and then we take that data and we say, okay, well, this is true for a sample. And because it's a good sample, which we'll talk about in a second, and a large enough sample, okay, because of that, we can make conclusions about the population, okay? If half of the children between ages 5 and 10 play with no more than 2 stuffed animals, then we can make some conclusions about the population. We could say, okay, well, maybe that's true about the population too, that all of the children will have no more than 2 stuffed animals. So we want to take a sample. It's a much more realistic way to collect data because it's smaller. We don't get an answer from every single person. We send out a survey. Typically, we might only get 40% or less than that responding to the survey. So we want a sample. And a sample is a subset of the population. Okay, so example if we talk about the number of stuffed animals, if we take that example, a sample might be taking 20 children from every elementary school in the country and asking them, or it might be taking 1 5-year-old, 1 6-year-old, 1 7-year-old, 1 8, 1 9, 1 10-year-old from each district in every country in the United States. If we're talking about the job that students at BMCC have, then we might talk about taking at a given period in time, taking 1 student from each class and asking them, and then doing that for multiple times throughout the day, okay? These might be examples of samples, but they're not always good samples, right? We want to make sure that we have a sample that's representative of the population. So a good sample, and this is really important, a good sample should be representative of the population, and typically we use a random sample. Okay, this is important because there are a lot of different variables, okay? Let's say that for the jobs that students at BMCC have, okay? Let's say that at a particular given time at 2 p.m. in the afternoon, okay, we took 1 student from every class that was currently meeting at BMCC and we said, what is your job? Do you have a job, and what kind of job is it? Well, sometimes there are variables that we might not consider. For example, the time. Well, a student at 2 p.m. may not have the same types of jobs as students who are attending class at 10 p.m. Okay, so we want to make sure that the sample is representative of the population, and a random sample will help us eliminate variables that maybe we haven't considered. Okay, so what wouldn't be a good sample? Okay, a sample that wouldn't be a good sample is if I'm asking how many hours a student studies, for a test. Well, a sample that wouldn't be good is if I went outside the library and I only asked students coming out of the library. Okay, well, why wouldn't that be a good sample? Well, students at the library are typically going to the library to study. Okay, they might be more studious students. So it's not going to be representative. Okay, standing on a street corner might be better, because at least then I'm not getting people coming out of a specific area where I know that that might change their answers. Okay, so what is a good sample? Good sample is typically a random sample. It's a sample that is representative of the population. A bad sample is a sample that doesn't consider everybody in the population. Okay, if we asked only people in the Midwest, who they will vote for in the 2020 presidential election. When we want to predict who might win for president. Right? This would not be representative. The Midwest, a lot of the states in the Midwest tend to be Republican. The data is going to be skewed. So we have to be careful. Okay, so that would be a bad sample. Another bad sample would be if we asked, let's take the library, or let's say asking students coming out of the physical fitness center of a college. How many hours of exercise they get a week? When we want to know the average hours students exercise at that college per week. Okay, again, this would be a very poor sample, because if you're coming out of a physical fitness center, then you're more likely to exercise, right? People who exercise go to the physical fitness center. So you're not really getting something representative. You also want to make sure that you're including those students who maybe don't exercise at all, okay? So this would be the difference between a population and a sample. Sample is a subset of the population, but you really want a good sample that is representative of the population. And most often, that's just choosing randomly from that population, okay? And the sample size may vary, and you are able to determine the best sample size, okay? The bigger the sample, obviously the more representative of the population it's going to be, but you can figure out, and you'll do this at another time later in more sophisticated statistics, you'll be able to figure out, okay, well, what's the best sample size, or what's the minimum sample size? What is the minimum number of people that I should be choosing from the population in order to get a accurate representation, okay? Okay, so we talked about where the data comes from, but then we have the way that we analyze the data, okay? So what do we use to analyze data? And this is it's sort of the crux of what you're doing, okay? Because what do we use to analyze data? We use statistics, and this is statistics class, right? So we use statistics to analyze our data, but there's something else in there that a lot of people don't even realize exists, because when we refer to these classes, we always refer to them as, I'm taking statistics. But statistics actually isn't the only thing. There's also something called parameters. And the only difference between statistics and parameters is that statistics are used to analyze the data that we collect from a sample, whereas parameters are used to analyze the data that comes from a population. Okay, so, and why do we call it a statistics class? Because we just said that it's really hard to collect data from a whole population. Almost always our data is collected from a sample. So when we analyze that data, we're using statistics. Okay, and if we were able to collect the data from the population, like let's say we wanted to know the GPA, the average GPA in a specific class, well, if we wanted to know the average GPA in a specific class, well, then it's easy to collect all of the different GPAs from everybody in the class and analyze it and figure out what the average GPA is. That would be a parameter, okay? So let's talk about the difference. Let's write this down. So statistics there are lots of different ways that we can do this. It's the organization summarization, interpretation, presentation, and analysis of data collected from a sample. Okay, what would be an example? It would be a conclusion about the most common favorite color among teenagers. Some of you may remember this as like being a mode, something that occurs most frequently, okay? Another example would be the average GPA for a college student. Okay, and if we're talking about any college student, then it would be pretty clear that we would not be able to collect from population. That would be very difficult. Okay, now if we're not collecting from just a sample, if we are capable of collecting from a whole population, then we call it a parameter. So these things would be parameters instead of statistics if we asked every teenager in the world what their favorite color is. They would be parameters if we asked every college student in the world what their GPA is. Okay, so here it's called a statistic because maybe we're only asking a sample of teenagers or we're only asking a sample of college students. It would be called a parameter if we were asking every teenager and we had data from every teenager. Okay, so these are the same as statistics, but it is based on data collected from population. So this would be a parameter if we asked every teenager, or if we got an answer, because asking is not enough, right? Sometimes we ask and somebody says, I don't want to tell you, or they walk away, or you call them and they hang up, or you ask a question online and they don't answer. So this would be if we got an answer from every teenager in the world, because we didn't specify what kind of, where the teenager lives. Okay, so that's the difference between statistics and parameters. Again, we typically use statistics because most of our data is collected from a sample. The sample, we want it to be a representative subset of the population. And the idea of the statistics is that we're using the sample, okay, to make conclusions about our population. So we're saying, okay, well, if we ask, 100,000 teenagers throughout the world, a random sample of 100,000 teenagers, and we figure out what the most common favorite color is among those teenagers, then we can say, okay, well, then it's pretty likely that this is going to be the most common favorite color for every teenager, okay, if we asked for the whole population. Okay, so we're not saying that every teenager has that favorite color. We're saying that that color is the most common among all the teenagers in the world versus just the teenagers that we asked. We're making that generalization based upon our sample. So that's the difference between statistics and parameters and the purpose of sample versus population. Okay, and that's it.